So now we are moving on to our second topic. Be it resolved that read-across from in vitro data and in silico modeling provide a sufficient basis for the presumption of endocrine activity of dodecylphenol and derivation of healthcare reference values. So Lisa Aylward will be our first presenter.
Thank you. So I haven't been up here yet. All right. I'm going to present this debate, which was structured based on an appendix from the recent NAS report on incorporating 21st century science and risk assessment. There was a very brief description of various case studies in an appendix to that report. This was kind of a fleshing out of one of the examples that was presented there. And of course, the disclaimer, neither Patrick nor I necessarily are ready to stake our careers on the arguments we're going to make here today. I'm going to give just a couple of slides of background and then launch into the pro position. So we're talking about this debate in the context of read-across, and so read-across is a practice that's being developed as a risk assessment tool. It's a guideline procedure described for the European Chemicals Agency, and basically you're looking to extrapolate or interpolate essentially properties or toxicity for chemicals that have for chemicals that don't have data based on data for chemicals that bracket either the structure or properties of the chemical of interest. And what we're doing in this case study is exploring the use of in vitro data to serve in lieu of missing bracketing data perhaps for a particular case. The para-Alkylphenols that we're talking about here are high production volume chemicals. There's a whole series of them structurally sequential. They're generally used as intermediates in the production of various other chemicals and products. And there has been endocrine activity demonstrated for some of the well-studied analogues. Dodecylphenol is used in a variety of oil and lubricant products, and I'm not going to get into a lot of detail here, but I think you can see that although this chemical itself is not something you necessarily expect to encounter with direct human exposure, you can see that the structures of these products that it is used in might lend themselves to degradation or release of the dodecylphenol molecule in environmental conditions or perhaps through metabolism, et cetera. So even though we don't expect a lot of this being directly people being directly exposed to it from use of this chemical specifically in like consumer products, the fact that it is a moiety that might be easily detached and in the environment or through metabolism means that this is exposure to this is would not necessarily be unexpected. The question is, why should we try to do a quantitative read-across here to establish something like a reference dose using data that would be less than sufficient and under other circumstances? There's a number of contexts where you really might want to have some sort of a quantitative assessment of toxicity of this compound in the absence of a typical database. So for example, if you're thinking about doing chemical substitution, either to put dodecylphenol into a product in place of something else that's considered to be problematic, or to decide to take dodecylphenol out in favor of something that you think might be less toxic. So that would be a situation where having a quantitative assessment of the toxicity would be very helpful. Similarly, if you've got measurements of this chemical in the environment, and you need to do some sort of a risk assessment, for instance, at a site where you're doing risk assessment of potential human contact with soils or sediment or other situations. And I guess I can imagine also if for some reason dodecylphenol were being used in a consumer product and had to be assessed in terms of potential direct human exposure, that would be another situation. So that's the type of situation, the type of context that we're talking about in this sort of a case study. And as I say, I think that's important to have a context in mind. So as Gary read, our resolution is that the read-across, relying at least in part on the in vitro data or in silico modeling, is a sufficient basis for presumption of endocrine activity and for derivation of a quantitative health reference value for dodecylphenol. So I'm just going to tell you, I think this is a no-brainer. We have both qualitative and quantitative data for both in vitro and in vivo for analog compounds. And of course, there's going to be uncertainty, and we have to acknowledge that and incorporate that to the degree we can, but we can't let that uncertainty prevent us from conducting this assessment. This schematic is from the NAS, the recently released NAS report on using 21st century science to improve risk-related evaluations. This was just released in January. And basically, the schematic asks us to think of our chemical of interest, identify appropriate analogs, look at the toxicity data for the most appropriate analog or analogs, select a point of departure, adjust that point of departure on the basis of either pharmacokinetics or in vitro activity data, come up with an adjusted point of departure, and then apply appropriate uncertainty factors to come up with your health reference value. So this is directly out of the NAS report, and this is the process I'm going to illustrate for you with dodecylphenol. There's a basic presumption of endocrine activity for compounds in this category. This has been published previously. That these products are known to cause developmental and reproductive toxicity effects, chemicals in this series. So this is a well-recognized structure-activity relationship group. The presumptive analogs that we might use for dodecylphenol include something like the butylphenol compounds, the octylphenol compound, the nonylphenol compound. All of these are in the series, and as you can see, particularly the nonylphenol, seems to be appropriate in terms of similarity in structure. When we look at in vitro data or in bioactivity data, this is an area, the interaction with the estrogen receptor, which has been really extensively evaluated in the ToxCast program. And in fact, they've really refined their approach to looking at the various assays that are available for looking at estrogen receptor activation. So not just binding to the estrogen receptor, but also activation endpoints in various assays. And they really have worked very hard and published a series of articles in which their goal has been to use a suite of these assays to identify with high specificity and sensitivity true estrogen receptor agonists and antagonists and be able to discern those from chemicals that are not active. And they've been very successful with that. The graph here is from their publication, most recent publication on this. And inactive agonist compounds are clearly identified as being inactive on the X scale, being low activity. Active compounds, the green dots, are identified as being active. They have a semi-quantitative scoring system that goes with this that correlates very well with known agonist activity, and the same for antagonists. So this compares activity to estradiol, and so they have a really extensive amount of work in looking at the very available assays and being able to classify in a semi-quantitative way how compounds interact with the estrogen receptor. So when we look at the available scoring from their work on the analog compounds that we're interested in here, we have this integrated estrogen receptor activity score, and it goes from a relatively low value for the butylphenol to a moderate value as we increase in chain length up, and we find that the nonylphenol, the dodecylphenol, and this is mixed dodecylphenols, and the para-Dodecylphenol have activities that are pretty comparable to the octyl and nonylphenols, and that the potency for these compounds have they're generally increasing potency, decreasing AC50 values for the estrogen receptor activity endpoints in ToxCast. So there's a very nice consistency and coherence here. There's a semi-quantitative relationship here that says the nonylphenol or octaphenol would be reasonable surrogates for activity, and I think we can go forward from there. So we have in vivo toxicity data for the rest of the other members of this series that we've been talking about here. We have chronic or subchronic repeat dose toxicity studies with low L's and no L's, and you see that they become more potent, more toxic as we get to these longer chain analogs. Similarly, developmental and reproductive toxicity data. Again, we have a situation where we have some increasing indication of reproductive and developmental toxicity, with the nonylphenol being just about as potent, that being actually one of the most sensitive endpoints for toxicity for nonylphenol. So that provides us with a situation where we have a close analog structurally, a close analog based on in vitro bioactivity, and I think that we can say that that's a reasonable surrogate for toxicity. So if we go back to our NAS scheme, we have our dodecylphenol chemical of interest. We have nonylphenol being identified as an appropriate surrogate and an available toxicity value, toxicity-based point of departure for that based on in vivo toxicity. Based on the information we have on the relative in vitro bioactivity, we would say that we would expect dodecylphenol to be similarly potent. And so we don't do any adjustment to that point of departure. And then we would apply some uncertainty factors to that to get a health reference value. And while we might normally say we want to have a margin of exposure of about 100 with a no effect level, in this case we might increase that to 1,000. And in our causal frameworks, we can see that the in vitro data provides us some specificity, some consistency between the in vitro and in vivo, some of the other plausibility and coherence arguments here that we have. So we think that, from our causal frameworks, we have some indication that this is reasonable. And of course, all knowledge is incomplete, but we still need to make decisions and take actions. So going back to our final determination, the answer is yes, we should do a quantitative read-across and establish a health reference value for use in these risk assessment contexts. And I want to just point out that if you don't do this, no quantitative assessment is a quantitative assessment, because you make a decision to clean up or not to clean up. You make a decision to substitute or not substitute. And when you do that, you're either assigning a toxicity of 0 or infinity, based on the decision, what decision you make. So not having a quantitative assessment, if you decide the evidence isn't enough, that doesn't actually give you an answer. You've actually made a quantitative assessment, even if you don't do that calculation. So, and with that, I will turn it over.